Ain't no walls that walks the line. There's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a great, to a duel. The old man, bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to any, making power for days. Don't listen to a word that the straight dope says. Might building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma volts a mile long. Sheila on the video making tones, chucking prongs. Burning, breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Bills.
Doc, can you guys hear me now? It's old man now. All right, sorry about that. Man, we're gonna go over what we're gonna do on the RAV, guys. So hopefully everything will work out, and Joe will be here in just a few minutes. Sorry about the audio. I got to take out my other headset. Got this one working again. So right on, guys. Yeah, I'm excited. And by the way, Sean, I did change the name. I know you were looking for it, and it is Resonant, and you're absolutely right. I fixed it all. So I'm looking forward to this, man. We got a lot of cool stuff on it. So, yeah, it took, like, I was going crazy, just so you guys understand. For the last, 4 days, man, I've been on this thing trying to just piece stuff together, put things in order. You know what I mean? Get everything, to everybody's satisfaction, and redoing things. So, yeah, it's been a little bit, man. So, yeah, we got to figure it out. When Joe gets here, we'll start running through it, man, and show everybody else what's going on, man. Sean, it's good to see you in the chat, though, man. I wish Sean was presenting with us, man. We got on Saturday, I think it's Saturday or Sunday, we're going to be on with Steve and Tesla Tech, and we're going to be presenting the RAV on his channel. I'll be on tonight with the Traveling Fools at 7:30, and then I'll also be on tonight with Mike on his channel for the Leads of Extraordinary Inventors. So that's going to be cool. So I got a busy night, guys. So yeah, we're going to rock it out, man. What we're going to do on the Traveling Fools channel, man, we're going to go through, Tesla, UFO, everything. So kind of the first time I'm on there. So it's going to be pretty cool, pretty epic. So thank you, Sean. Yeah, Sean's here, man. Awesome. Yeah, I really do. When you feel better, Sean, I want you to be able to record your part. So no matter where we go, you're on there with us. It's important to us. You know what I mean? So, yeah, I'm gonna be streaming on this channel here. So just keep tuned into my channel, man. You'll see it pop up. I'll stream that at 7:30. I'll be on Mike's channel as normal, so I can leave you guys the link for that one when I pop over there. And then the Traveling Fools, they'll let me stream it to my channel, so you'll be able to get it there. Sorry, my camera's not working real well. Give me just a second, guys. There we go. Hopefully this thing works out. There it goes. Joe, what's up?
I had a dilemma. I had a dilemma.
Oh, man. Doug got you or what?
Yeah, I clogged my toilet. I don't have a plunger. a little early in the episode for that, but what are you gonna do?
Yeah. Wow.
Yeah, I didn't do anything like I didn't overload it either, I don't think. But whatever. Something happened.
Okay. Did you want to talk about it or leave it alone?
Oh no. I think it's okay. I'm just doing the things that that I needed to do in the 10 minutes of my life that wasted in between me getting off of work and going live. So, you
Oh,
know, I'm getting acclimated. I'll get the chat up and everything. But yeah, go ahead, proceed.
yeah. I was just letting everybody know, man, that we're gonna run through the presentation. It's probably gonna be a little rocky, but because I don't know exactly where you chime in at. You know what I mean? I have to put a little marker on the page so I know to stop. If that makes sense to you.
Yep. Well, I guess this is why we are working out the kinks now. Yeah, I mean, really, I looked through all the slides. Everything that you have there is great. It shows the best of it. I think that when I have to supplement it, hopefully, hits the marks, right? And altogether, I think that it should be a successful endeavor. I'd have to say. So, anyway, well, while I'm getting set up to be able to even go through that with you, um, did you want to share maybe what the idea is here with the audience as far as where we want to present it in the short term and everything, and where
I
we're going to
did.
present it? Oh, you did. I
Yeah.
missed that part. Sucks. Well, all right. I'm almost there.
Not a problem, man. Yeah, it's kind of one of those things. I was letting them know that it was kind of stressful, man, because like I would try to bring everything together, right? And then get the pictures and everything. And then, man, Sean got out his red marker yesterday and took me to Disneyland and you know what I mean, rewrote a lot of it, which is good, which is what we needed to do anyway. But it took me some time to put it together last night. And I had to get it in time for you to be able to do your thing.
Yeah, for sure. And I know that stuff takes a long time. I mean, look, you see the dumb memes and stuff that I make all the time. You know, you know how long one of those takes to make, even though I'm pretty quick about it. Like sometimes I see the opportunity in a conversation, and then by the time I'm done with it, I'm like, an awkward amount of time has now passed to
Oh,
put this. You know what I mean? Like,
supposed to be like a quip where it's
right,
like
it's
right
supposed to be
away, and you're
quippy,
like,
right? I mean, because I know exactly what that meme needs to be instantaneously as soon as I see whatever it is I'm going to prompt it. But that means that then I need to be able to make it,
yeah.
you know. But anyway, not neither here nor there. I'd have to say.
So in what you have, Joe, you said you're going to do a pre before the presentation, or is it after I show the first slide?
Well, yeah, I thought that we would give like a little intro, and I didn't write that part yet. I mean, I could wing it, but it would just be a little intro. And then when you right as you start the presentation on like the first slide, just go into the configuration. If I have time tonight, I'll make a couple of extra slides at the same format and stuff. That way, at least the configuration is like laid out, whether I gotta either take it from screenshots or just draw a simple diagram, whatever it is. That way, at least there's something.
No, no. Well, what it is, as long as you let me know the number on the page, because all the pictures and stuff are labeled A's and B's. So as long as you
Yeah.
give me the number, I'll just put a little tag on there, and then I'll know to stop. You say what you need to say, and then I can start again.
Okay, cool. So, are you ready?
Yeah, let me pull it up.
All right. I hate to be reading people, but until I have this memorized this way, it's going to be all ums and uhs and stuff like that if I don't read it. So,
I
and then
think you.
don't forget my ADD tangents that I go on.
Oh yeah, yeah. We're good, man. Oh, okay. So you can go ahead and start, and then I'll get into the reading of it. If you just want to give the quick open, or do you
So
want me to just start?
I'll do a little improv here. So we wanted to present to you today the Resonant Arc Vortex, or RAV. The Resonant Arc Vortex, we believe, is the next iteration of plasma technology as it forms under circumstances not found elsewhere. And we think that its application and in practical use is there to be gathered. And we wanted to take the time to explain the configuration to make it, how it's formed, and what the observations are of this phenomenon. There you go.
Hold on. So let me grab it right here. Okay. Resonant Arc Vortex, or RAV for short, a new way to create fusion in self-organizing plasma. And we're discovering transmutation through ionized gas state. A resonant arc vortex, or RAV for short, is a pulsed high voltage reaction between an anode and cathode that produces coherent spheres of plasma separated by sheaths.
Okay.
No, the videos are 20 seconds long.
Is it going?
Yeah, does it not play?
I'm super glad we have this dry run there, homie.
Oh, hold on. Okay, sorry. I must be on the wrong one. Let me shut down the other one.
Oh boy. Okay.
Sorry.
It happens. Working out now. That's why we're doing it.
Yeah, all right. So we'll play the video again.
All right. Hold on. Try again.
Eh,
I was
sorry
like,
about that.
it's like I love that video.
Wow. This is like a total cluster right now. There we are. Now we see it?
All right. There it is.
Okay, so let's correct this. Okay, we'll go back. All right.
Start again. Take two.
Yeah. All right. Resonant arc vortex, or RAV for short, a new way to create fusion in self-organizing plasma, discovering transmutation through ionized gas state. A resonant arc vortex, or RAV for short, is a pulse high voltage reaction between the anode and cathode that produces a coherent spheres of plasma separated by sheaths.
All right. There's the RAV.
Yep.
All right. So my part kicks in after this video.
Right at this one?
Mm-hmm. So what separates the RAV's formation from a more conventional method of plasma production is the separation of differentials in the initial configuration. This separation is maintained by the use of a ceramic membrane, which exploits the ceramic's natural insulative properties, porosity, and absorbency. This allows for the focused energy from the anode to pull and collect electrons from the negative potential bias in a controlled, isolated manner within the material. This promotes an equilibrium state to separately form between the negative electrons made available by cathodic electrolysis of water and the positive ions generated by the anodic arc. This is demonstrated in the video as a pink and purple hazy negative plasma, which is seen being drawn out of the clay by the positive arc and accumulating on the surface in zones separate of the arcs, leading up to the RAV's formation. So that was this video description. And there you see it again. Same process.
Nice. The sphere itself is organized in stratified plasma with temperature differentials and resonance frequency. RAVs are typically confined by their own magnetic field. Ampere's law links current density J to magnetic field B. The moving changes of plasma create a magnetic field that in turn help confine the charges of self situating loop.
All right.
You got another one?
Oh no. Just a thought, and it's funny that we're thinking this out on a live. You guys get to see how this works behind the scenes, although we usually just do it off the cuff, obviously. But um, I think that I should, if something is attached to a video, since the videos lack any sound, I think I should just narrate over the video, so we can work that out on the back end before tomorrow.
Yeah.
But yeah, so after this slide, I'll do my point on that.
Okay. So I go back to my other page. RAV temperatures. RAV temperature when running is 5,000 Fahrenheit to 50,000 in Fahrenheit. Temperature per zone when the experiment is shut off. Do you want me to read those or?
I mean, yeah, I would. Range between 250 and ambient temperature in whatever within the sphere.
Okay.
Yep.
So the inner sphere is 250 Fahrenheit when the experiment is turned off. The black layers are the sheath layers in between each temperature zone. The inner layer of red is 130 degrees Fahrenheit. The closer to the core layer is blue at 190 Fahrenheit. And the center core is 250 Fahrenheit.
All right. So real quick, so the RAV displays remarkable thermal containment as shown in the thermal imaging, proving that the high temperatures required to sustain plasma is contained within the sphere and disproportionately transfers heat to its host environment. The heat signature is tight with limited internal temperature diffusion, which is displayed by the IR as a non-gradient concentric banding, implying sharp temperature differentials nested within the sphere. The nesting layers inside the RAV's inner geometry is further supported. Oh, wait, no, that's for the next one. Sorry.
Oh, you were going into the next one right there?
Yeah, accidentally.
Oh, okay, sorry.
But now you play the video and then I'll say it. So that's what I was saying. All right. So the nesting layers inside the RAV's inner geometry is further supported by multiple repeatable observations of known anomalies and defects. The phenomena observed in the video has been identified as a kink defect, a helical plasma filament ejected from the core of the RAV. This plasma kink is formed as it is twisted within the innermost layers of the sphere due to asymmetric torsion between the nested strata or compression zones. In this instance, the asymmetry is caused by the observable RAV satellite in the video, which is in a position locked with the RAV itself. This satellite is the cause of a tidal pull upon the outer sheath of the RAV in a fixed location, causing asymmetry to the internal geometry and thinning the external sheath opposite its position. This gives mechanism to both the formation of the kink as well as cause for the location from which it is ejected and oddly enough returned.
Plasma is a quasi-neutral gas of ions and electrons. It supports collective behavior, meaning particles interact through long-range electromagnetic forces. RAV outer plasma layers and frequencies. I think I should define this a little bit. The upper layer is 96.1 kilohertz. The layer just below it on both top and bottom in green are 100 kilohertz. And the yellow layer in the center is 104 kilohertz.
Okay, so I have a thing on this one too.
Okay.
So Photon HARP testing again indicates that the RAV surface contains multiple frequencies banded at the axial point, meridian, and equator of the sphere, and they are in resonance, and also are an indication of the rate of rotation. In addition, the light emission pulse that is observed at the point of maximum expanse appears to be proportionally related to the frequency measured at the equator, which has been measured to consistently time at slightly faster than 1 pulse per second. This pulse rate was calculated via video frame analysis at 30 frames per second, although the accuracy at 30 frames per second lacks the accuracy to directly correlate it to 104 kilohertz exactly. The timing consistently showed 1 to 2 frames less than 1 second in the intervals, allowing us to draw the relationship. As observed in this video, the arc of the plasma initiates in a variable form incoherence. As the relationship between the anode and cathode is established through a channel formed within the membrane, the waveform stabilizes in resonance as seen on the oscilloscope reading. The creation of the exchange portal in the membrane allows also mark formation of the RAV, which directly corresponds with the system falling into resonance. In addition, there is a direct correlation between the parallel but opposite current vectoring of the anode and cathode. Once the negative electron path to the anode is made and the positive ions penetrate the membrane to the cathode, the opposite two vectors achieve asymmetric equilibrium. The vector paths broaden due to the polarity bias, creating a third magnetic vector. This is directly correlated and the cause of the plasma's compression, rotation, and the RAV's formation.
To create the RAV, you would need a high voltage AC flyback with a frequency modulation, a porous surface like clay or pottery without a glaze coat. An anode should be made of stainless steel and a cathode wire attached to a stainless steel plate with a lip on it. 4 drops of water are placed around the clay or under it, while a wet cotton swab is dabbed on the top of the clay where the anode is directed 10 millimeters from the surface. The anode should be 90 degrees to the surface of the clay.
All right, I got a narrative now. So as shown by Nathan a moment ago, a high voltage source is required in order to reach the current levels required for the plasma to form and to allow for the anode and cathode relationship to establish. Equally as critical is the general attributes of the chosen membrane samples. As previously noted, clay or ceramic is a reliable substrate for the RAV formation. Flat terracotta blanks are used as a benchmark for testing. It is hypothesized that purpose-built multi-layered ceramic with each layer specifically tailored to maximize the intermedium reaction would optimize and control both RAV formation and function. The use of the stainless steel bowl promotes formation and precipitation of hydrogen during electrolysis. And once formed, the RAV displays unique characteristics that can both be observed and measured. I don't know why that's not supposed to be there. Wah, wah.
Nice. Yeah, the goal is to produce a resonant frequency between the anode and cathode be around 96 kilohertz. When the anode is first discharged and reduces the frequency to 50 kilohertz until it locks into a spot in the clay where the water under the clay can touch the water on the top of the clay and create a temporary cathode connection. Okay, so this part, Joe, we need some kind of talking when I show the pictures.
Okay, well, I could do that because I have all this. So,
Okay. Well, I'll
um,
keep going. You want me to keep going, or you got a spot in here?
well, I could just say my narrative now. So, as previously explained, the formation of the channel is critical to RAV formation. All testing has confirmed that once the channel is established within the membrane, a RAV can be formed nearly instantly once a minimum power level is achieved. The channel is formed as positive ions consisting of oxygen, nitrogen, and metallic elements from the anode, being iron, chromium, and nickel, are carried by the arc and forced to permeate the ceramic structure. The ions are further drawn into the ceramic by electrolytic attraction until the ion deposition penetrates the full thickness of the membrane to the cathodic side. It is hypothesized that the deposition forming in the channel may be a gradient of metallic oxides nearest the anode and metallic hydroxides nearest the cathode. There is also a potential for novel hydrolytic compounds or reactions. Further testing is required to confirm the true composition of the channel. There are strong indications that the channel formed maintains a negative charge bias and potential after formation, providing cause for the ability to start up without a cathode. It is worth noting that removing the initial water and cathode and running the RAV on the channel removes most of the hydrogen potential, which may impact the layering and free electron availability.
As the plasma starts to form on the clay, has what looks like carbon or deposited on the surface in a carnivorous structure. Uh, that's not the right word. Cavernous structure. This structure will act like a, well, it's kind of repeating the same thing you said. Act like a cathode from the point forward, an original cathode removed as a second anode.
Very cool. I like that.
God, that's bright.
Yeah, you ain't kidding. You're
Should have
leaking
been,
fast.
should have been in the room with it. You wouldn't be able to see for a few minutes.
Nah, man, it's crazy.
Yeah, we got a remark in here, by the way, that the one on the left, every time it goes down in value, the one on the right goes up.
Yeah, and you were saying that there's also a correlation with the pulsing as well.
Yeah, that's what I mean. It's taking it from the other one based on the design of the flyback. Yeah, you see the one on the left looks really clean, and the one on the right just bursting out. Okay. MHD equilibrium. The plasma structure is created by the connection in the new cathode of carbon, which the rotation of high voltage on the anode and spins in one direction. the main equilibrium condition between the magnetic pressure and the plasma pressure, where P is the plasma pressure. This is the essence of magnet hydrodynamics, MHD, which describes plasma as a conducting fluid.
As Nathan also pointed out, the equilibrium state of compression and rotation is an MHD effect. As with all MHD processes, RAV has both unique novel qualities and high potential for practical use in both conventional and emerging applications.
Joe, this is the video you see where the actual RAV will split. There it goes. It's splitting from that and building a second one.
Yeah, check that. It's rad. That's rad. Building a satellite. I don't think I've ever seen that video.
Oh, it's really cool. Look, and it pulls it back in to take a little from it.
Yeah.
And then
then it dissolved it because it burned up its electrons.
Yep.
It wasn't flying on the because it deviated from the channel. It wasn't big enough to get a new draw through to create a new channel, so it just dissipated because it burned up the electrons.
You'll have to write that down and put it in while we watch the video.
Well, we could comment on these videos naturally. In fact, you know that us talking naturally is so much better than
no, I get it.
Whatever we're trying to accomplish here.
Just want to make sure we don't have dead air in the middle because we're getting some of it. You know what I mean?
Mm-hmm.
Okay, electric field, magnetic field drift. I should let you explain this, Joe. Did you have an explanation for it?
I do. Give me 1 sec. Well, I was okay. I was going to explain it a different way, but I'll do it this way. So, as I had mentioned before, in the formation of the channel in the clay, there's a penetrating factor of the anode depositing ions to make it through the other side. And inversely, there is an opposite vectoring negative electron stream, making two vectors parallel to one another. The negative side, okay, is able to make it through much easier, the clay much easier than the anode putting the ions through the clay. Okay, once both the electrons have a direct flow to the anode, and the ions from the anode have a direct flow to the cathode, the equilibrium is then established, and the two vectors broaden, okay, and they cross at 45 degrees, and the change of the relationship of those two vectors creates a magnetic component, which becomes the third vector. The cross motion of the electron and the ions, okay, in conjunction with the magnetic field that's formed as a result of the two, are the mechanism for the spin that the RAV experiences, and is a major component in both its formation as well as keeping the internal geometries strata separate through the asymmetric differentials of the layers that create the sheaths. So that's sort of the best I could say off the top of my head.
Nice. Each layer of plasma will have a sheath. A plasma sheath is a thin boundary layer that forms between the plasma and a solid surface. The temperature builds out from the core at high temperatures and lowers the temperature for each sphere of plasma until it reaches the outside layer of plasma. This representation is when the experiment is shut off, not while running.
So the sheets and zoning depicted allows for the separation of differentials in an equilibrium state within the RAV. This allows for RAV to maintain its stability. The sheets are the boundary layers where one zone ends and the other begins. The sheets are formed and maintained by torsion and compression caused by the differentials of each layer. These differences between layers, though coherent, cause stress or pressure increase of the boundary plasma, increasing the sheet density of both layers in that zone. Since the layers are in coherence, there is no energy loss due to this interaction, as both layers in the zone interact in a laminar fashion.
Okay. Sorry, Joe, I screwed up on the slide. This is actually why it's in motion, not while it's done. So I have to fix the slide.
Okay.
So just pointing it out so you know, because it doesn't make any sense for me to say it turned off, because then it'd be temperatures and temperatures bleed together. There's no sheets in between once you turn it off. You know what I mean? On the clay.
Yeah, I get that. I mean, there's definitely defined zones of temperature differential. There's
Right.
there's no zone where it's room temperature in between it. So
Well, I'm just saying I put that in there because we were giving a disclaimer on the other ones, and I shouldn't have it on this one.
okay,
My fault.
yeah.
The testing includes a HARP device connected to an oscilloscope used to measure the speed and resonant frequency of each layer of plasma.
We could talk. We should be talking over these videos so we don't have the narratives for.
I agree. That thing is awesome, by the way.
Yeah. So Sean had built this device, and I can't say that my understanding of it is 100%, but my understanding was that it's able to use light wave frequency to kind of bounce off of the different surfaces of the RAV and then be able to get a measurement based on those return signals.
So what we need, if Sean, if you could do it, is just a like schematic of it, just like kind of like, you know what I mean, just a little image of it, and then you put up there what the indicators are that you used for each one, like a photon detector or you know what I mean, whatever it is, how you picked it up, and then that way this would be a lot better. But you're right, we got to start talking over these things. A thermocamera is used to determine the temperature of each layer when the RAV is turned off. The residual heat can be measured on the clay to determine the layer sizes. The voltage and amperage and frequency of the pulse wave going into the AC flyback can be monitored by voltage and amperage meter and the oscilloscope. For safety, a Geiger counter is set up 1 foot away from the experiment where the operator has eye protection.
That's so you don't get nucleated.
Like Nathan.
Yes. Oh yeah. What was the results of that?
Yeah, well, Nathan's got retarded new ones coming.
Oh.
No,
So you're giving a warning out that you have yet to
yeah.
yet to heed your own. Well, listen, liability is a thing, buddy. I'm in the insurance business. I get it.
Yeah, glowing parts. Let's see. The goal of the RAV is to study plasma and resonance govern a self-structuring plasma field. If an outside resonance frequency can be applied to the resonance frequency in the plasma to increase the amplitude of the plasma to the point of full potential for energy production. The RAV is proven to form in 2 different resonant frequency zones, and we hope to find more zones it can form in. We will also explore the environmental conditions that the RAV can form and exist for prolonged periods of time. While we While there are many camera effects each time we experimented, we did not use those to come up with any conclusion in this presentation. We are, however, we're taking a closer look at them to see if there's something of merit in the future. Sorry, I'm getting tongue-tied. So, and then we got a couple of slides here, Joe. Did you?
Yeah. So, well, this
You're
is
gonna have to describe
self-explanatory.
this, huh?
I said, well, this is self-explanatory.
Oh yeah. Well, that was pretty much the whole thing of the basic slide part. Then this is all just comments from us on what we wanted to show before people ask questions.
Yeah. So I want to talk about this real quick while we have it up because I've been in classic Joe form. I think before I look, but I did this experiment and I did several others with quartz and different rocks and so on. Before I ever looked to see if anybody else ever did it, I just kind of wanted to use what I knew to guide me. And then I started looking up other people trying to inject plasma into quartz and in any form or function. All right. And there's stuff out there. There's not nothing. But here's what I can tell you. This is as good as it gets. All right. And in fact, everything that I've done with this is as good as you're going to find, online at least. There's no such thing as this lighting up to that degree with triboluminescence. Triboluminescence is, it occurs when the lattice breaks, and it's very, very short lived. It's not constant and it's blue. So clearly not what we're dealing with. Not to mention it's isolated. It doesn't throw off enough light to actually illuminate the entire piece of quartz, even if it's crystal clear, in any way, shape, or form. So this is way beyond triboluminescence, or anything of that nature. Not to mention, people trying to put plasma into quartz has not been successful. Trust me, I've seen it done when Nathan and Sean both tried it. I saw it done on multiple other people's channels. I've seen it when labs have exposed quartz to plasma in all sorts of different ways, and it always just sheaths right over because it's an insulator. But that's the point. And if you look at when we were talking about the channel formation, you realize quickly that what this is doing is it's injecting ions into the quartz itself. And as soon as it has enough ions built up in the quartz lattice, then it's able to go in. And that's why this works the way that it does. Because at the end of the day, it still is trying to find the channel. See, this thing is on top of the channel for the most part, right? The primary part of the channel. That quartz is trying to get to that channel. It knows it's there and it's in contact with the quartz. So the quartz has a relationship to the channel. So it's trying to get to that channel however it can. And that's exactly what causes it to want to create the channel through the quartz. Which
so
it does.
Can I say this real quick, Joe? You got 3 different states going on right here. This is non-penetration of the quartz itself. This right here shows it, hold on, going around it. When you see it right here, you can clearly see it going around it. So you're only getting so much lighting effect that comes out of it, and it's barely lighting it. Once you get to this effect, you have penetrated the quartz, and now the luminescence coming off of it is every piece inside that quartz structure is lit.
Every single last piece.
So, and then you get to a state.
That
Yeah.
state.
Yeah.
That was a great frame to stop on.
Yeah. Where you have too much energy inside of it, and the piezoelectric energy is combining with it, and it gets into a destructive state because the resonance frequency itself does not match the frequency of the quartz.
Correct.
So it cannot stay together.
That is it. It shakes the lattice apart, and it causes fractures, and the fractures will just grow and grow and grow. And the more fractures there are, the the easier it is for the plasma to get in there and do its thing. So it becomes an expeditious process once that occurs. But there are points here that are worth making. What is pure quartz crystal? It is silicon oxide, right? O3. Well, what do you get when you hit a pure piece of quartz in this manner? You get wild oxidation going on. You have immense amounts of ozone. Like, however much ozone generally would be created by like Tesla coil full go, right? It is like exponentially more than that. It's because it's breaking through the lattice of it. And that's exactly what it's doing. That's exactly what it needs to do, to a greater or lesser extent, in order to make its anode depositions in there. Because if you remember what happens when you make the anode depositions in there and then you make the connection to the cathode, well, then it becomes a self-sustaining cathode. Now, because you have a piezoelectric in this and the plasma itself is inducing a current, if you were to induce the cathode into the quartz, the question then becomes, do you need the anode at all to sustain it, right? You don't need an anode or a cathode to sustain it, provided that it's in resonance, right? Because what's blowing it apart right now, because it would happen, is the fact that it's out of resonance.
All right, Joe. So we got a couple more slides just to show it.
Okay.
And this is just one where you start to see everything start to blacken around it. Even the piece of clay looks darker.
Yep.
And there's that black light effect that was going on that took the clay itself and made it look like soot was on it, but there's nothing on it.
There it is.
And then this one's one of my ravs, not as clean as Sean's, and it bursts out everywhere.
Right. So we should take the time to discuss the fact that there are differences in how some of the experiments are done.
Mm-hmm.
And when it's done based on the initial protocol, that's the recipe for the most stability, where the light and the heat is not escaping as readily. There's just far greater containment, but this allows you to see what's inside. And that's valuable when you're trying to understand what's going on.
Yeah, look at that.
Oh yeah.
That's like a massive amount of energy right there.
Yeah, and that's not convexity of the lens creating the star effect. I mean, yes, your eyes are convex too, but I'm here to tell you that based on the environmental impact, when it does that, that's exactly what it's doing. It's zoned out. And those beams are actually you could see that they're brighter on the walls where those beams are, and darker otherwise. And in person, it's much more apparent that those beams are actually beams. It's not just refraction off of the convex lens of your camera or the convexity of your eye. There's other things indicating that that's what's happening.
I think in this one, Joe, when you look at the upper right, you see the red on the tin.
Mm-hmm.
It's giving some kind of a light, like I don't know if it's laser.
Well, that's what I call it.
Effect. It's definitely shining light in one area.
Well, yeah. So I mean, we had identified that in two three colors so far in red, green, and blue.
Mhm.
We've seen that effect numerous times where it's not present in the beam itself. It's not emanating that color, even with increased color saturation modification to examine it. And you'll see that the light is clearly a coherent type of laser light on the surface.
Which is there, by the way, as you do the experiment, not part of what your camera picks up. This is something that you see in person. Just so we understand that particular one in the upper right, you'll see that in person right on that dish.
Another effect that's present in person that might seem like it's a camera trick is the prismatic effect that occurs within the light shining out of the RAV. So it's actually breaking it apart into the full prism spectrum in the rays a lot of times. And the RAV itself is, and I mean, this is coming from a guy that welded and stuff, for several years, every day. That's just not something that you get. That type of white level, is very similar to like maybe a plasma cutter, but like even with like TIG and stuff like that, anytime that you're adding inert gas to it, you don't have that pure white like this thing produces in air, which is wild to think.
Hmm.
But then that goes prismatic, and you could see the breakup of the white light into the full rainbow spectrum, and it kind of biases in that like red gold spectrum for whatever reason, ever so slightly.
So we have this one in here, and we have to mention it. We saw the two come apart, the plasma come off of it, and try to separate, and then went back together, and then dissolved. This stage is something completely a little bit different than that. It'll still dissolve back up into the anode. However, we're going to look into more of what it could be because it's almost in solid form at this point, except for it's in super hot plasma.
Yeah, it acts like a thick viscous fluid the way that it flows. But what's interesting about that is that it also flows at such a rate as far as the perception of it is concerned, that it seems counterintuitive as to how it would be so thick and viscous. But the way that it moves and the behaviors that it has suggest that it is, just at a very fast current.
Yeah, it reacts like liquid. You're absolutely right.
Yeah, like a thick liquid, like
Yeah.
jelly liquid.
It's something to look into. It's not something we're definitive on at this point.
Well, that thing is seeking, is what it's doing. So, for whatever reason, it decided not to go after the channel, and it's going to seek, a better way. That's what it's doing. Yeah, man, that's what it does. It's always looking around. It's always like looking to make that connection, and once it finds that connection it wants, that's where it goes.
Okay, so that would be all the stuff we have in there for the presentation, except for one last thing. And it'll be this right here. Hold on, let me pull it up. This is the photon harp, or yeah. What did he say up there?
Yeah, photon heart. What is it?
Yeah. He has a name.
Three photodiode wiring. It doesn't say, but I mean, I was calling it the photon harp, and I haven't been corrected yet, so I'm pretty sure that's what it is. Sean, go ahead and tell us if we're wrong.
Yeah, we'll add this into the presentation. So
Right, you have three levels of this. You have Sean, who's like, I'm doing this, and I'm gonna have the equipment to do it, and if I don't have that equipment, I'll figure it out in a cost-effective manner. Then you have Nathan, who's like, well, I got tons of crap, and out of everything that I have, I'm going to make this work. And that's definitely going to happen because I have so much. And then you have me. I'm like, I have Chinese, Chinese chopsticks and, wonton soup container. Um, so let's do something nobody else has ever done online before. You know what I mean? So there's like 3 levels of it. And I'm good with cameras.
Yeah, there you go.
That's one thing I am, so like when you see like the videos that I put full resolution and stuff and whatnot, it's like it's 4K, you know, 60 frames a second, manual focus, manual ISO, setting the shutter speed and stuff, like as far as like even the capture rate, aside from the frame rate and everything like that. So that stuff, like it's so far so good, coming out pretty damn clean and stuff, and I like that because I think that gives like the best evidence to show. Yep.
Well, I think, to be honest with you, we got a little bit of cleanup to do. We got to put in Joe's part of the presentation over some of the videos.
Oh
You know
yeah.
what I mean?
Oh yeah. I'm a fucking disaster, Nathan.
No, I think for a first run through it, it was
For a
fairly
first
good.
run through, it's not bad. We did it live, man. There's no shame in that.
Yeah. Yeah, you got it raw, guys. So, all right, let's have a little fun now. Sean sent us some more stuff, Joe. Are you ready to see it?
Oh my god, I want to say yes, but I never know.
Well, Sean's just so everybody understands this, Sean's a super genius, okay? Not many people come along that does what he does, and it's really cool to see some of this stuff. So we'll throw it out there. This, by the way, anything we show at this point is not going to be part of our RAV presentation. That's going to all stay in one particular field as the RAV. This is an experiment outside of that.
Oh yeah, I know what's coming.
Oh yeah, you do.
Oh boy, eat your heart out, people.
Oh, I should probably start at the other end.
Probably.
Yeah, sorry.
All right, people. Now, as far as usefulness is concerned, I'm not convinced. Okay, but what I will tell you is, you ain't never seen this happen before, and this is an eat your heart out moment. Who knows what's in? Go ahead, take a look. Who knows what it is?
That's his compressor.
Yeah.
What you're looking at is the RAV in a vacuum chamber.
Well, not so much, but let them guess.
Okay.
They know. You ever see Flubber? You ever see Flubber, right?
Oh man. You call me crazy, but I love that sound in the background. For whatever reason, it just sounds more epic.
Cathodic fireball. Yeah, well, I like that. At the end of the day, though, this thing already kind of has a name.
Love it. John says it's gonna say that name.
All right, listen, it's fine.
Yeah, this thing is epic, man. So I'm just gonna tell you, this thing isn't. It doesn't appear like it's light on the surface, like a. I don't want to say it, like a lens shooting out. You know what I mean, from your laser. This thing is in 3 dimensions, guys. This thing is built like ball lightning. It's Not a laser at all. It's high voltage between the anode and cathode and the vacuum chamber. And it builds out in 3 dimensions. And then you can see the light come off of it just like it would the RAV. This is in a, I want to say it's a 2-gallon vacuum chamber that's clear. So it's about 12 inches by 12 inches and then 12 inches deep, somewhere right around there. Yeah, Sean's got it going on, man. That's for sure.
Sorry about that. I have end of the world situations over here.
Oh, again?
No, today's a hell of a day. Guys, ball lightning much?
Oh, dude, just saying. Yeah, you can see the dimensionality in that. You know it's not flat.
Oh no, it's not flat. That thing is flubber. I keep on saying it's flubber. I'm pretty sure that's how Robin Williams made that thing in the movie too. Like it was like some chemical reaction with some plasma, and the next thing you know, it was like blah, 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 blah.
Sean ain't gonna let you get away with that name. He's already named it.
Yeah, I'm pretty sure that that's been written about though in like stories throughout time about how it'll go through walls and either go through you or then decide to electrocute you or like do all sorts of crazy shit.
Ah, it's because things don't do that.
Right, Paul. Things don't do that. I know, things don't do that. Yeah.
Oh, Sean says that. Yeah, he says a calf all day long. Well, you're making it, buddy, so it's all you, Sean. It's all yours.
Oh yeah, man. You can name it anything you want, but I am pretty convinced that that's exactly what ball lightning is. That's it. And you got to remember something when you hear about it, it's loose, it's this or that. There's always something more that you can't see. When something steps up exponentially in its volume and so on and so forth, that thing's up in a cloud, and you don't see it. Or it's beyond, like in the upper crust of the atmosphere.
I want to say thank you to Jiggly Jess, man. Thank you for the donation, man.
Right
I really
on.
appreciate
Thank
it, man. I didn't build this one today. This is Sean Calderon calf, as he calls it, but we all know it as ball lightning, man. He's got it. Thank you again, by the way.
Yeah, man. Yeah, no, this is great stuff, and this was a total accident. Like, it was a pre-test to see if you get RAV to expand in the chamber, and it was just like, all right, let's make sure we can hold the air out and turn everything on, and whatever, and then this is what occurred. So cool. Very nice. Not typical because I've seen them try things like this before. Like them being anybody. I've seen them try to make ball lightning and things of that nature before, but they're not successful. And when it comes down to why, I believe, is because of how the anode is configured. That's an atypical anode setup. And I don't think there's any getting around that. The anode is kind of given a free rein to be able to search around the cathode for the state of equilibrium, and that's allowing it to get a higher density level since it's not fixed and restricted or directed in any way.
So we'll show this. Oh, hold on. It's the next one. Yeah, you can see this thing from top view. By the way, just so everybody knows, what Sean did is in order to get around the vacuum chamber, it's just a clear vacuum chamber. So what he did was he put copper tape all up, down, up the side to the top, and then back down on the inside and down on the bottom in order to get the cathode portion into it. And he connected the anode straight to the top portion right there where it has his little valve that puts in the air. So that's what you're seeing. He sets a thin wire hanging from the top, and so it moves around. Just so you
Wait a
understand the setup.
second. Hold on. Duh. Because he ran it on the wall, he's adding. He has the length and the width, and then he's adding the height. So when it's going path of least resistance down, and it's forming, it still has an electron feed from that tape on the side. So that gives it its volume. You know, that's giving it its volume. I mean, that's as simple as it kind of gets. Now that I'm thinking about it.
Well, a vacuum chamber, no matter what, has the walls as the negative. You know what I mean? And they're configured all the way around it in aluminum. So it wouldn't be much different.
Is it though? I mean, it looked plexiglass, or is it just the aluminum frame you're talking about?
No. I'm saying most vacuum chambers are aluminum and they're high pressure. So they're 360 degrees of aluminum with a little opening in the front.
Right.
You're right. Where Sean's is basically clear, so he doesn't have that. So he puts a tape there to mimic it. Yeah.
So
that's all I'm saying.
I mean, yeah, no, I mean, I'm just kind of throwing stuff at the wall and seeing what sticks. But I mean, for what it's worth, and this was my criticism, and it's certainly not a criticism of Sean or his work in any regard. But as far as a configuration inside of a vacuum chamber and trying to form RAV, I don't see this working. So, you know, there's that, but whatever.
Well, the two different effects and treat them as two different effects. That's
yeah, they're two different effects, definitely, but there still is got to be a way to form RAV inside of a vacuum chamber, or you know what I mean? Like,
so we'll show this.
That can't happen. It's just not that configuration.
So just so you guys know, Sean did this under vacuum pressure right here, and you can see that the actual plasma coming out is not the right type that you would need to start the RAV. This doesn't have enough straight up plasma going to it to burrow the hole in order to create the cathode. So it wouldn't do it with that pressure that's in there.
Right. You would need a primed cathode, you know, that already has the channel that has been recently used, so it has a fresh charge on it. Because, by the way, guys, I'm here to tell you that the cathode piece that has the channel absolutely holds the charge. Okay, it absolutely does. So yeah, I know about that, and it'll amplify charges too.
By the way, we should add that to the presentation, and I'll just say this, because what happens is when you stop running this thing, okay, and you want to turn it on again, and it immediately starts.
It's in my part, Nathan.
Oh, okay. So so we'll just say this. And then when you leave it for a while and go away, depending on if you ran it that day or 2 days later, that day you might start up right again. But if you run a couple days later, you need the water again to restart it, just as how it's built. But Joe will tell you why.
Yeah, I mean it's holding. Okay, so when actually, let's talk about this, because I don't think we've really talked about it too much on the live, and I kind of blew through it when I did with this. So there's a massive significance, okay, to RAV and that channel. And I will put it out there that you could form RAV on things other than clay. I did it on a rock. I showed you that, right? But
someone was asking what that rock was, by the way. Sorry.
that was just a piece of porous mudstone. It's like it's like a sedimentary rock, really kind of compressed, but still porous, and mostly probably silica, if I had to guess. But like really, really fine, and not a piezo at all or anything like that. But still has potential because it's silica, and it's that sort of thing. And then whatever else made it into it, I suppose. But realistically, the composition is secondary to a certain degree to the porosity and insulative properties, right? So those are the two things that make the big difference. Now, that rock that I was using is higher density and less porous and less absorbent than the clay. So, like, I'm not getting as big of a hydrogen effect as if I were to just use a straight piece of clay. But that's kind of what I had and what I was playing with and what I wanted to test. And since it worked, if it's not broke, sometimes don't fix it, right? So that's what I went with. Now I recently took the rock, which I have right here, very good. Okay. And I flattened out a couple spots on the bottom just so it sits nice and flat.
Okay, hang
And
on,
I
let me-
also flattened out the top. Okay. And yeah, it's a little hard to see. Okay. So if you could see
There you
a
go.
spot
We
of
can see it.
discoloration in the middle, where it's sort of brown, where the rest of it, I mean, it's sort of like orangey brown, whereas the rest of it's sort of greenish brown, right? Well, that's the channel in the rock. It doesn't show up as crazy as it does in the clay because again, it's more dense. Also, I use a copper anode, and most of the exchange that I'm going to get into this, the ionic exchange, is going to be copper. Okay, so there's going to be various coppers, copper oxide and copper hydroxides and those sorts of materials that go through my channel. But the channel does go all the way through the bottom. If you see that dark spot right there, right?
Yeah, I see it.
Yeah, right where my finger is now. Right, so it does go all the way through. The so the rock, it like again holds a charge. If you run a piece of quartz over it, or if you run another rock over it, you can actually feel it grabbing right over that channel.
Oh,
So
yeah.
you know that there's a potential. Also, if I take my little zappy Tesla coil guy with the gas tube, right? And I put if I zap it directly, it'll start screwing with my computer. If I put a piece of quartz on top of it, it'll start controlling my computer entirely. And if I hit it with the little zappy Tesla coil, so you know that there's a lot of amplification going on. You know it's throwing the energy off. You know it's storing the energy. And
Yeah,
then it
but
goes to that.
let's talk about that when you put it on that cathode rock, right?
Mhm.
The one you formed it on. So I saw it yesterday. You had a little piece that was on top of it, but then you took the Tesla coil and you recharged the rock itself on the bottom, and then it had an effect because you would take it and rub it on there, right? And then you would all of a sudden see it move to the left or move to the right. You know what I
Yeah,
mean?
I'll show it again.
Real quickly, because there's a charge state on it right when he was doing it.
All right. So I'll show you that live right now. But before I do, let me show you the piece that I'm going to put on top of the rock. Okay.
Okay.
This is a piece that I just cut. It's smoky quartz. Okay. And there's a reason I use smoky quartz. It's because it's irradiated with iron already. So it already has iron in ions in the lattice structure.
Mm-hmm.
Okay, which should allow for the plasma to do work. But what I did was I flattened it both sides so it'll sit perfect. And I burrowed it out in the center with a sphere diamond bit. Okay, so it's cupped. And then I went into the middle of the cup, and you really can't see it, but there's a pinhole in the middle of that cut that goes about 16th of an inch, 1/8 of an inch, something like that, you know? So what I'm going to do is I'm going to throw my anode just above that. I'm not putting it in where it's like pinned in like that. I'm going to put it like I normally would. I'm going to give the RAV the proper surface to actually use the dish to sit there and spin and stabilize in it to promote it, that ion exchange within the smoky quartz. And then that should allow for the precipitation of the ions through it, in this case, copper ions. And then we should be able to, I would hope, maybe get RAV in there, and it'll probably blow it apart because it's not in resonance. And that tends to be the problem. But I want to see. It took a lot of work last time to get that arc into the quartz, but I don't think it's going to take nearly as much with this one. That's sort of where it's at. So we'll see where it goes. Society says won't work. Well, I guess we'll see. I already did it. It just breaks.
Yeah.
Right. And it's not a mystery why it breaks. It breaks because it's not in resonance, and I know this, right? So I very well expect this one to blow up also. The question is, between it being smoky, having the the ionized iron already in there, and then having the dish to promote it and all that sort of stuff, is that going to allow it to happen faster? And that tends to be the big question. I suppose that it will. That's my guess. But all right, with no further ado, let's go ahead and see if I could make things bleep and lose the chat and maybe my phone. Oh, I might get zapped too, because the only way I could show it to you is to hold it. So that'll be
you're gonna
fun.
get zapped. Yeah.
Ah, shit. I'm gonna knock things over in the process. The wire's caught. All right, hold on. Figure this out. All right. I think we are in business now. Oh, look at this guy. All right, here we go, people. Well, nothing's going to happen here, remember. This is for purposes of showing you that this...
Yeah, a little bit of spark I could see.
And the spark is going right to the rock like you would kind of expect. So, oh, look, it was just moving there and I wasn't moving it.
No, we see it moving a little tiny bit. Yeah.
It turned. It turned strange.
You created a charge state in there.
By the way, I mean, I could feel the energy coming off this thing like insane. It really does throw it out. All right, now here's... I'm going to regret showing you this. Oh, and the ozone's kicking up too. I don't have a good way to show you this, really. Okay, sure. How about on a bottle of Allegra? You see how it's not, right? Why? Ask yourself. See, this is how you figure out how things work. Okay.
Not zapping it at all.
That doesn't do it, right? Oh, and by the way, the only buzzing that was happening was because my finger was choked up. Let's do it one more time. What do you think? See? Okay. Now watch this. This isn't conductive. It's because it's charged. Oh, the fact that my computer hasn't screwed up is mind-blowing. Oh, wait, I didn't zap it on top of this, did I? Oh, yeah, I did. That usually sets it off every time. I don't know why it's not.
Charge it up, turn the rock around.
Oh, I'll tell you why. If I put it on my table where you guys can't see it, it'll probably do it. Oh, now it's not doing it at all. Straight high weirdness, man. Oh, but when I tap it, the thing, man, things are acting weird. It is what it is. It does. It's not doing what I said it would, but then it's doing other shit. I have no idea. I think I became part of the equation when I was holding it and zapping it.
Hmm.
Yeah, there's a little high strangeness thing that goes on with this stuff. Um, that I have theories about, but frankly, I mean, I'm not there yet. We'll share it when I have proof. I don't like making claims.
Yep.
Either that or people will just end up calling my shit like an electromagnet, and then I'll have to be like, well, it kind of is. I don't know.
No, no. It's the effect is simple. It's static electricity effect. It's the PVC pipe and the towel. How you rub the towel and then you take it to a soda can and how it moves it. That's the
Mhm.
effect that's going on here. Because the rock itself, now that it has that cathode that's built into it, now can hold a charged state.
Okay, so there is more to that I didn't go into before, but when when the ionic deposition is occurring, it's occurring in a gradient, right? Between the anode bias of the pin where like the pinpoint where it's kind of going in, and then as it travels in, it gets more and more cathodic bias. Okay. So the deposition is actually taking place through that exchange in the environment of the cathode. So when the deposition actually ends up, like grabbing hold and depositing into the structure of the pores or the lattice or wherever it's going, right? It's doing so with the negative charge bias already. And that negative charge bias gets kind of cemented in to that deposition. So it's always going to have a bias toward the negative side once you reach a certain point through the material. And that's sort of what my understanding of it is. This also coincides with, by the way, right, whenever we talked about restructuring of materials through resonance and different charges and stuff like that, and electrets like Sean was working on and stuff. It's no different than that at all. It is literally making the rock into an electret, which is just super ironic that Sean was working on electrets all the time. He sees this, thinks it's nothing to do with electrets, and then the whole entire thing that makes it basically function properly is a fucking electret. You know what I mean? Like,
Yeah.
it just so happens to be. And just like an electret, the thing isn't throwing off charge just all the time. If it's sitting there, it's just simply sitting there. But if you go noodling with it and stuff like that, well, then it starts to throw off like its potential, and that potential kind of gets renewed because it gets held up in the structure of the ions that deposit inside the cavities. Really, really cool stuff. And it works with both physics and chemistry at this level because since you have the interaction of different matter occurring under these very hyper-specific conditions, and they're all in volatile states at this point,
Mhm.
because they're broken down so fine, they have this predisposition to want to mix, especially when you're dealing with hydrogen that wants to bond with everything and oxygen that wants to bond with everything, you know, and now all you're adding in is charge bias. So it's really, really cool to think that that's sort of what's happening here, and how the deposition that I see in my experiments, because my anode is different, because my uh, membrane is different, actually could have a whole different set of properties than that of the initial configurations,
Yeah.
because the chemical reactions that are going on in the deposition is not the same. You
Yeah.
know,
I wanted to share this real quick. Sean sent us his configuration for the calf. So there's the box there and the copper strip. How he got around sealing it without drilling holes.
Right on.
Yeah, it's pretty cool. That was a neat little trick he pulled right there.
Honestly, that's a Joe trick if I ever saw one, man. That's straight props. That's like, oh man, I got to do things, spend money, effort, something, or just like tape and ribbon. Yeah, tape and
Yeah.
ribbon.
Huh.
Now, I'm more complicated than he is. I would have done tape and ribbon just to get superficially past the seal point, and then I would have run an insulated wire, just me.
Hmm.
Because I don't want the cathodic leaching. You know what I mean, personally, which is why I don't think Rad would work set up like that. But neither here nor there. It was a very smart idea to get around the problem, and it showed us something brand spanky new.
That's right. Hmm. Oh man. Yeah, we got a lot of cool stuff going on, man. So I'll just say this, guys. Sean hasn't been feeling, you know what I mean, up to snuff lately. He's been kind of out. We're hoping that at some point he can record some parts of this presentation with us and give us some description in there because after all, this is his project 100%. And although he's nice enough to put Joe and I's name on it, his name should be number one at all times on this project. We're just helping him build this thing out and getting the presentation together and showing it to people, but ultimately it's his. And we would love for him to introduce it in the beginning. You know what I mean? And then take any part he would like in it and say it as soon as he's ready. And then hopefully when we get to a point where we have this presentation down and we start going before a lot of audiences, we absolutely want Sean with us.
Right on. And, I know that it's kind of the goal at this point to be able to get in front of like the Tesla Tech audience and, not just on this, actually get there and do it and, promote it in that sort of way. And, I hope and pray that, God willing and everything, if we get to that point next year that Sean is able to do that as well, and that we're all able to do it, frankly, because it's certainly been a group effort. And the big thing is that like I just this has only been going on, and I've been very humbled by keeping all of my records, videos, photos, work, this, that, the next thing, and then it's all in chronological order and whatnot. So like I flip through, and then I sit there and see, man, this has only been going on for like 2.5 months. Okay, and the
Yeah.
amount of progress, understanding, research, development, next steps, etc., that has occurred in 2.5 months, given the circumstances, is absolutely profound. And thank you, Darren. You're the man, brother.
Thank you, Darren. I really do appreciate it.
Sending over them kangaroo dollars.
Nice, love it.
Right on, man. But yeah, I mean, just how far it's come so quickly, and the direction it's headed that's something else. And I know that there's probably going to reach a certain point in time where like I see what I see with my quartz situation, and then I'm gonna have to call up Nathan and be like, Nathan, I'm stuck. You need to pick up my torch, but like you got to hear me out here. Like follow it this way, follow this course because like it's working. But you do what you can.
Yeah. No, yeah, dude, that's kind of the thing. One of the cool things that happened during this whole process, just so you know, in working together, is we kind of got used to each other in how do I say this? Just saying it how it is. Because a lot of the time, Ben, you kind of come out with things and you're like, well, I don't want to hurt somebody's feelings, but I'm kind of the guy, and I think Joe's the same way. Just spit it out. Because I'll be honest with you, man. When you tell me the wrong direction, I'm spending like 2 hours in CAD that I don't need to spend in the wrong direction. And I would have been easier just tell me I'm an idiot and let's do it this way. then
Yep.
so it's a learning experience for me.
We fight with gloves.
Huh.
You know what I mean? Like the
Yeah.
gloves aren't coming off. That's what it comes down to. Sometimes we do see it a little differently and whatnot, but uh, I think what it comes down to is that it does it really matter in the end? Because I think that what you already see and experience with it, and like the things what's going on, right? That's what matters. You see the nuancy stuff of the hows and the what's going ons and what's in it and what's not and all this, like it becomes a bit of a moot point once you simply realize that with what you see, you could already meet your means to an end. It's just a matter of being able to convince the people that are going to be skeptical and going to want to shoot your work down. That needs the full blown explanation because and I feel a little silly, and I'll say it because I'm not ashamed. Like I went on that the Paradigm Drift show, which by the way I really enjoyed going on that show and then watching it back and everything like that. But they kept on asking me, "Well, what are you going to use it for?" And they're like, and they made the assumptive like energy, and I was like, "Yeah, energy." You know what I mean? Yeah, energy. That's the easy one. And I went with it. I was like, yeah, at this stage, energy, taking energy from it, seeing what we get out of it is exactly where we're at. But the implications are great. But I didn't want to focus on that because, well, we don't have the data on that yet. We have lots of empirical evidence and assumptions as to what this means, right? But really, like the people that try and convince, that naysay the process or dispute what it is or don't see it for what it is, like those are the people that you need to be able to have the correct information, to have the data, to have every single breakdown. You need to know how many gray hairs around the asshole exist. It's just exactly what it is, and you got to be prepared for that. And I think that at this stage we are. Um, you know, Even if we don't agree 100%, it actually doesn't matter because as long as the answer is solid and makes sense, you know, then they could go fuck off. That's it. And I think all the science is there to back it up. And Nathan hates it when I say this, and I'm almost baiting him to sit there and get into a pissing match with me, like because it makes for good TV, I guess. But like realistically, none of this breaks any known physics, and that's kind of to me the beauty of it. You see, you don't really have to argue with anybody who's stuck in mainstream ways because you thought outside the box, solved the problem. Okay, solve the problem in a unique way. Okay, but then applied everything that they've been saying is going on all along to it as to exactly why it's happening, and then showing them that the result is something they said couldn't happen. You see, that's where the beauty of it is because they really don't have anything to argue with you over at that. And I could sit there and come up with new theories and this and that, the next thing, but honestly, you think I'm that smart to come up with something new that nobody else has thought of or said? Like, I mean, who do you think I am? Because I don't think I'm that good. Like, no, might as well just do the application science and rather than create a theory, right? Do the experiment, let the theory follow the experiment, and then let your knowledge guide you forward. And that I think is the key. That's what science fucks up. You see, they come up with all this harebrained stuff that they could never possibly ever prove. And then the best they could do is simulate it and be like, you see, it's here, it's there, it's wherever it exists. And well, it's like cool, that's math, that's simulation, that's algorithm, but like where is it? Okay, well, you can't, right? And there are certain parts of this that you just simply have to accept because not only do we not have the tools, nor will we ever, to be able to measure certain things, but I don't know anybody does. I don't know anybody does.
No,
No.
we're good, man.
Yep.
No, not at all. Not a problem. Here's one thing I'll make a point on, and I was making this, Joe, and I think we're on the same page after last night. It's this right here. So just so everybody knows, whether Sean's creating this in the RAV form or something else, he's using the same power source. And I just wanted to point that out. Now, the effect is 100% different. The conditions are different, so it gives a different result. But all the power goes in is the same part. So if you get some of this equipment, you're going to be able to run a lot of experiments that we do right out of the box. And this thing is the absolute best right here at doing that. And I think Sean's proud of this part right here because he keeps telling me about it. These are 4 AC flybacks that are inside of his power source. And he says it makes all the difference in the world. And you can see he has frequency modulation in there, which smooths this thing out to be a beautiful signal coming out without a lot of fuzz or mistakes going on in it. So just so you guys understand this, he's got this one. So if that's what you want to do, is do all these experiments, get this, you'll be able to do them. But you can see that they're completely different results based on the environmental structure that goes on around them.
Mm-hmm.
Yeah.
And then, mind you, I'm doing it a totally different way, entirely.
Oh, completely.
And does it still work? Oh, it does. Because what you realize with RAV is that it's a game of differentials.
Mhm.
Okay. And so long as you separate your differentials and you have some type of intermedium to allow it all to coalesce in and interact in, then it works.
Yeah.
And weather works the same exact way. All right, like I'm gonna say that part. Like weather works that same exact way. Look at a hot and cold front, right? Hot and cold, high and low pressure, right?
Mhm.
Different moisture, humidity gradients. That acts as the barrier between the two in which the interaction occurs, right? Which is actually why not only the moisture gathers there, okay, but why that's cause of major thunderstorms and major weather events.
Mhm.
Is all because you have one thing on one side, one thing on another, but then you have this boundary layer that exists that's neither of the two, is resisting them both and allowing them to fight it out. And when they fight it out, that's what occurs. You start to get, major cloud formation, high humidity, upper atmospheric, high charge states that want to dissipate from one to the next. This is what you get when you start to do that. It just follows nature. That's it.
Mhm.
It just follows nature. And the moment I saw this experiment, the first thing that I said was, the anode is pulling the cathode. And it always does. The anode needs the electrons, you see. That's always how it goes, right? But the arc is pulling it down, is pulling it up.
Hmm.
So once you start to understand not only the physics, but once you understand the energy end of like the physics, and frankly, I mean, I'm just that stupid, or I just am that uninformed, but I don't even know where in physics energy vectoring is defined. As far as the interactions of energy vectoring, and it's a electromotive force.
Mm.
You
I
know,
don't
but
know.
I mean, it's probably Maxwell's equations if I had to guess, but
Could be.
it's that's the whole idea here.
Well, I'll say this. So the reason I like to make a point out of what he's using to build it is because we got a lot of different names for things out there. Okay. And it's the same power source that's going on in everything. And that's why physics use lasers a lot, because they believe that's the same power source that you use everywhere. So it's a consistency thing, right? And you run into the same thing with high voltage. I think the high voltage is more accurate, that it could build out the laser and do everything else, but they use lasers. Okay. Now, that means that in our upper atmosphere, when we go to make a ball lightning or something, it means that you have to just understand energy changes a little bit based on the environment. So we see it mostly in the thunderclouds and stuff, right? So it goes from like a DC voltage to an AC voltage, which you see as lightning. And that's why the RAV experiment did not work inside the vacuum chamber right away, is because you're not getting that effect. You're not getting the amount of energy condensed well enough in order to burrow in to make that effect work. And when you don't do that, it dissipates everywhere. So it'll give you an idea of why it happens during lightning storms and stuff like that versus why it doesn't any other time. Or if you start shooting lasers up into the sky, or microwaves, you start to see funny effects going on in there because you're playing with high voltage. And if you can get a rotational spin going, then this kind of event can form. So it's just important to understand that. People think there are a lot of different things, and they're named based on what the effect is going on, not so much the power source is any different.
Well, energy is all the same. We think about it, describe it, name it, and label it in all sorts of different ways, but realistically, there's no difference. Sort of what it comes down to. It's yeah, whatever. Like what becomes interesting, I think, more than anything, and something you've been saying forever, is like the interesting nature of potential. And that's sort of the realm where like a lot of these things that we do deals in, because no matter what you're putting in, it becomes more like what the potential is. Um, and when you start opening up and pulling apart, you know, things, well, the potential is nearly unlimited.
Oh yeah.
And that's sort of where it comes down to. So anytime you have broken locality, you have uh you're pulling apart the you're pulling apart the environment to allow whatever you just made to fit into it. And what is inside of that is not inside of the environment. And that has a much greater potential that can fully be exploited in the proper ways. And I know I've kind of said it before, but you know what? I think people like hearing it and I like saying it, so I'm going to say it. The beauty of the RAV and the irony of when we started working on this and Sean came out with it, and how it coincided with the you know uh diagrams that I was coming out with to show the ancient symbolism in conjunction with how that forms field geometries.
Hmm.
What you start to realize very quickly is that the reason that this thing, and why I'm so excited about it, why we come back and talk about it time after time after time at this point, right?
Hmm.
Unlike a lot of the other things that we talk about, is because this is the example where it's all there. You see, all those pieces are there and they're in motion. Um, and I guess you could either see it or you don't. But I know that there's some smart people out there that definitely picked up what I was putting down. And then there's some equally smart people out there that still thought that the idea here was taking those vector charts that I kind of made, right? And then thinking that that's the way that you just wind wire. And, that's a mistake. You see, this is about field geometry and not circuit geometry.
Hmm.
So it's about how you could induce the environment and the energy charges in their directions, to then form those patterns. And wildly, that's what this is doing. but it makes sense why it's doing it. So it's not crazy. And I've said it before, but I will say it again. My prediction, and this is so unproven, but I believe it, right? If it's happening on the top, it's happening on the bottom, but it's happening inversely. And that means that if you have something extremely compressed and extremely hot in the center and extremely bright, and all these very apparent things, right, at the top, that means that on the opposite side, okay, where you think nothing is going on, you just have the opposite going on. So what do you have? Exactly that and everything in reverse, right? So it's extremely diffuse and it's extremely dark. And it is, it's all these things that would be very, very, very difficult to observe because the way that we're exploiting it is to bring the what we can observe, into that equilibrium, into our observation, right? But everything that it's not, I believe, exists right underneath it. And that becomes to prove me wrong. Because once you realize that the anode has to burrow through to reach the cathode and vice versa, right? In order for it to form at all, you realize that there must be something going on the other side.
Mhm.
And it's just simply opposite. And that's it.
Nice.
It's high craziness, man. It's there, and we should find it.
Yeah,
Because
I agree with that.
Because anytime they say dark this, dark that, whether it's matter or energy or whatever, Aunt Jemima or whatever the fuck they're trying to say, is dark. It's there. You just got to find it. That's it.
Well, yeah, it'd be good to explore it, put it out there so everybody has it so they can stop the conjecture and we can get on to the next level. Hey, I just want to tell everybody I threw out 5 free Old Man Builds memberships. I hope for those people who get it, go into the members area. All the videos you saw today will be up in the members area. A lot of them will come out as shorts, and I name them just so you know, with Sean's electric theory and then Sean and his Rab experiment, stuff like that. I have some to put up from Joe, and I have some from put up for myself to add to that so that you guys can check them out. But I've started to do that, man. And everybody seems to like it. That every time we show something on the live, it doesn't always go out. So I want to make sure I put it in the members section for everybody. And then one of the things we do on some of the days, and it may not be today, I don't know what time we have, but the Discord that we do afterwards, it's a free chat with Joe and I, and then anybody who joins in. So anybody who likes to do that and just wants to say hi to us or just wants to get their point across or something like that, you're absolutely welcome to do it. And then I don't know, we might have some time today. Joe, do you have time?
I was about to say I was gonna exclude you from that and be like, well, I don't think Nathan has time today, but I do. You know what I mean? Like, no, but I mean, hey, if you have a little bit of time in between, that's awesome. We'd love to see everybody there. We're there for Q&A, but also you got it's your guys' platform to kind of converse to, whenever you want. And it's important that these ideas kind of get talked about in the community and then kind of brought to the head, here if you feel good and comfortable doing that, it's that networking that takes the people that are talking about the information, listening to the information, and then collaborating about it. That's what that's all about. I love that it exists. And I will absolutely be there for a little bit after the stream tonight for sure.
All right, Joe. I'm looking. Did you send me that? You did, didn't you?
The Discord link I did at some point recently.
Yeah, let's go through some funny stuff.
Yeah, if you're not a member of the Discord, go ahead and click the link to get an invite or whatever. I don't know how that works exactly.
I just pop on the link and you're good to go.
Yeah. You got to join it and then whatever, and then you. we'll get on there and we'll talk. And frankly, I'd love to hear from all of you guys because, um, there's so many names that I know, so many people that I feel like personally connected with that, like, you know, if I could be standing next to you, I wouldn't know, right?
Nice. Okay. Sorry, I'm looking for it. There was just so much conversation that went on in the backstage here.
Wahoo he put the dunce cap on himself and sat himself in the corner.
There it is, guys.
I mean, listen, that's what it's there for and stuff. But it's certainly not a critique of the stuff you put up there because I love that you do it and I love that that's the engagement. But like eh, when you throw high quality stuff up every so often, you just know that anything you're gonna click on is the best and worth watching. If there's stuff just going up there all the time and it's like, well, somebody might like this, well, then at that point, it kind of takes away from it a little bit. That's all. And welcome you on into the Discord. Yes, it just popped up on my phone. I saw you join. So and don't time yourself out, man. You're a good guy. Yeah.
Yeah, no, I haven't seen anything in person, man. If they did, I'd be waving them down to take a ride. Okay, don't ever think I wouldn't. No, I have not. You're not scaring me. I don't care how ugly the alien is. We're going.
I always say, I live upstate New York these days. If you are in proximity and would ever like to get together to see some, quartz explode, find some quartz and or hang out and just talk about stuff in general, that's where I am. I make myself available. So
Yeah, Deadfish saw something. He recorded that stuff going off, man. We saw that a while back. It was awesome.
what, his documentary?
Oh, his documentary was awesome, but he also recorded the quartz, you know what I mean, building up and shooting out and then building up and shooting. Remember that? Yeah. So
Dude, I have a green 5 milliwatt laser. It went 50 feet over my head, and the laser was absorbed a few feet from the craft. Yeah, I mean that sounds like some what do you call it? Whatever the place out in the desert is,
oh yeah, Area 51.
No, not Area 51. You know what I'm talking about, the TV show, the place that the government used to own. How come Skinwalker Ranch? Thank you.
Skinwalker Ranch. Okay, totally different desert.
Yeah.
Got it. There you go.
Yeah, well, I mean, honestly, I mean that's really cool and all, but like I've been saying, man, that Rav that Nathan has, the thing is literally the fucking demon core. Like it literally blows out black light that absorbs all the environment. That's just like it makes a disappearing laser pointer beam like in like it makes it feel like insignificant. Like I mean, just the whole idea.
Yeah.
Dude, that thing haunts me. And the only time I've ever seen it, I'm like almost like borderline like reluctant to share this, but like, at a period like my meditation practices have like cooled down a bit. I'm at like a couple times a week now, which is less than I like, and whatever. But when I was in prime time, meditating a couple times a day, like in a formal sense, I don't know, man, weird stuff starts happening sometimes. And like I saw something like that one time in like a lucid waking vision situation. I don't know. It was probably like a sleep paralysis state more than anything, but it was like a djinn. I don't know how to describe that, but it's like a djinn. It was like black fire and smoke that was like light absorbent, not radiant. But it was something, you know what I mean? It was like something like it was what it was, but it was something that it's not. It was the inverse of what it was. And that's exactly what this is. This is like it acts like light, it's light, but it's the inverse of light. It absorbs all the light. So, and that's like literally puncturing all of his organs when he does this for your entertainment.
that RAV thing, by the way, when we run it way out of frequency or something like that, when you get it to start, that's when you start getting all these special effects and stuff like that. So when you start talking about black light, and it's literally black, not purple, not like, you know what I mean, when you can plug into the wall, it's literally black.
It's
That,
light absorbent light. Light
yeah,
absorbent light.
it,
That's
it,
what it
it
is.
gives hope for if these things build out like stars and stuff like that, then why is everything dark around them? Could be this, could be something else, but it's interesting that they coincide together. That's the part
Well,
that
there's
I
something
think is
weird that I
interesting.
noticed though, is that that black situation often, not always, but many times has lights, like red light spectrum, like IR spectrum light that rides just over the surface. Like it's like it rides with it, that IR light. And it's weird because it's at like this frequency that you can't see, but like you can pick it up on the photo sensor.
Hmm.
If you jump the levels. So yeah. Yep. Hashtag not a shadow. Like
Oh no, not at all.
right. Hashtag not a shadow.
Yeah, that's freaky. It does this in person. I was telling Joe there's no reflectiveness on the bottom tray, and he's like, "What do you mean there's no reflectiveness?" Because it's just not there. So we show him this. It's like freaky how there's nothing. You can't see anything under there, and it's a real shiny surface.
Listen, our friend here, Nyan is Ghani, our little alien friend,
Hmm.
says, I wonder how they are phase shifting out of reality. Well, I haven't seen you here before, but that was my guess. That was my guess, like all along. And I say guess, I have empirical evidence. You know what I mean? Like as to that's what it's doing. But yeah, I believe these things to be four-dimensional objects that actually exist in a fourth spatial dimension, and I believe them to be tethered to our dimension, and I believe them to oscillate ever so slightly out of phase with
Mm.
our dimension, which gives that gives the cavitative pulse effect, and it gives a great explanation as to why there is, under Sean's experiments, by the way, and I'm being very clear because there's differences here, right?
Hmm.
Sean's experiments, there's almost no light bleed off these things. You could literally burn your retinas out if you look in its direction, but then you look at a dark environment surrounding it. And that's because it's not letting it out, except for that it pulses. Why does it pulse? Because when a 4D object moves in and out of 3D space, it appears to grow and get smaller, which is exactly what it does. And when does it pulse the light? Pulses light at the point of greatest expanse. How long is that pulse of light for? Instantaneous. In one frame on a camera, 60 frames per second. Right? That's how it is. So as the center of it passes into 3D, it's at the greatest expanse. The light is in the center of the thing where the heat is. And that gets pulsed out, and then it draws back. And when it draws back, you could still see the luminescence, okay, in the other layers of the 4D object. But at the same exact time, you don't get the environmental effect that you would otherwise get for that level of light. And that's about the containment. That's the containment all day. That's what's incredible about it.
Mm. Have you
And
tried putting a
being with
solar
radio.
cell? I'll have to pick up a small one and put it next to it to see how much energy is coming off it. You can get that. That's interesting.
I'm not familiar with Charlie Hall's photon theory. I'm not I'm the worst pseudo physicist that exists because I will tell you all day about all sorts of shit that I believe, understand, and know. And I don't know many other people's work, and I don't know if that makes me a genius or mad. So, I'll leave that to your discretion. Yeah, I don't really know too many other people's work, and I've never heard of Charles Hall.
Nice. Yeah, I have like, just so you know, glasses to look at this thing. I've tried sunglasses. I've tried welding helmet. Nothing's good. The next thing, try is laser glasses, and past that, it's pretty much put a camera on it, get your eyeballs out the way, and get a box set up, because this thing is just gnarly. You can't really look at it.
Well, yeah. I mean, truth serum here. There's 100% chance that you'll, with like the proper equipment, that you'll be able to see it without hurting yourself better.
Mm-hmm.
There is 100% chance that no matter what you put over your eyes, that you will never see beyond that outer sheath. You see, it's not letting light out. It's not letting heat out. It's not letting energy out. It doesn't light the light bulb. It doesn't heat the clay. It doesn't light the environment. And you're supposed to see past that.
Yeah.
Sorry, buddy. Guess what? Environment's not coming in, and it's not coming out. That's how that works.
Yeah.
So, like, there's certain things that, like, you have to accept based on the fact that it's doing what it's doing, right?
Yeah.
That's it. Like, I mean, that's it. But that is why I looked at the lens effect. Okay, to throw that out there, because if there is a chance that through a convex refraction, okay, where it's basically split, right? Then you could draw the relationship and make your interference pattern, etc., that you'd end up with a hologram. But I don't know if you'd end up with a hologram of the entire thing or just the outside. But it doesn't really matter. I mean, it's still an interesting thing to explore on the side, whatever. But there's no seeing the inside of this. There's no telling what the inside's doing. There's no measuring the heat on the inside. You have to work off of the data in which comes through.
Yeah. So, yeah, we'll have to put it in some kind of container, though, and have some sort of vacuum on it. But I think it has to be created before the vacuum goes on. If we use a vacuum, just so, yeah.
Well, you got to remember something. Vacuum defeats the purpose. But if it could show you something about it, then cool.
Yeah.
And that's always what it's about. That's what experimenting is about.
It may go into a vacuum when you put compression inside of it with a magnetic field, once you contain this thing and force it to go smaller, and then build up the amplification of the resonance, then we might start seeing some weird stuff going on, like the worm and stuff like that. Because you got to remember, you had that magnet that was there. That was a whole different, thing that came out of it.
I mean, honestly, I don't know that shouldn't be a component in it, frankly, because it formed so fast comparatively at the time. You see, it wasn't as established at that point. It didn't have the set charge in the clay at that point to start up instantly. It just didn't, right? And when it started up under those circumstances with the ring, okay, the inverse of that experiment was the ring flipped the other way. Where it wouldn't form almost whatsoever. You see?
Well, it helped the rotation, is what it did. It got it to there faster.
Without a doubt. Now, it also did probably cause defects, but that said, that might just be a tolerance issue. Like, realistically, like you move the magnet ever so slightly, you move the anode ever so slightly, you adjust it, make sure 90 degrees. Okay, everything's flush, everything's good. What's your spacing? Okay, cool. Where's your center? Okay, your center's here. Perfect. You've marked it all out. It's all there. Where's your ring go? Your ring's this diameter. Bang. This is where ring got to go. You just move it that slight amount. Maybe that defect doesn't exist, right? And then all of a sudden now you have it in a much greater efficiency at a higher rate of speed with a higher potential. And again, I think that all the empirical evidence, again, right, implies that you are getting an ion feed through these black hole things. Like, and I say black holes, I mean the channels, right? You're getting that was a bad choice of words given the subject matter. Okay, is there a black hole? I mean, there fucking could be a black hole, but I'm not going there. I don't think there is. It doesn't really matter. All right, the channel, right? So it's getting some kind of ionic feed off this channel regardless. You have the cathode in place with the water. There's a higher potential there. Then there's a hydrogen component, right? If you're able to hold back the moisture and accelerate the hydrogen precipitation to the through the channel, at that point you feed it and it's going to be a monster. It has to be, because then the middle zones will grow. The anode just like it goes and goes and goes because it's feeding off of electrons, you see. So like that'll just keep going regardless until it burns up its electrons and then it's out. And we saw that when we played that video.
We did.
Right. Saw that
it
when
was
we
a
played
good
the
video
before.
to see. So you can see what's going on. Yeah, it was
right.
Good.
So as long as you maintain that feed, then you're good. Now, there is such a thing as overloading it. It'll collapse the other way. Okay, so you can't have too much electron feed, but you need to keep it proportional to the power that you're putting in. So once you get it started, you want to get started at a certain state, you want to be able to increase it, which increases the draw, and the medium should be able to hold back the moisture, okay, to prevent it from wicking out and oversaturating, but keep up with the hydrogen production. And I think that that's totally plausible once the membrane is modified in a couple of ways. It's like the material could be like optimized. The fact that there's tons of hydrogen escaping into atmosphere could be optimized, right? So these are next steps for the thing. Like that's sort of what it is. Like we need to up the hydrogen level. If you want fusion, you're not doing it with water. You're gonna have to do it with heavy water. You need deuterium. So, we haven't gone there yet, but I'll take that leap. I said it from the day one. You seal it out. You feel it out. You just make sure that you have a closed system on your cathode side, so you don't have the escaping situation. Heavy water, deuterium. You get the precipitation of the deuterium hydrogen at that point.
Oh, real quick.
And then you could have yourself some fusion, boys.
What did you call the material? Because we keep calling it carbon, but it could be something else. There was a specific formula. Do you remember what it was?
Yep. So the ionization from the anode, okay, would be atmospheric, right? So you have oxygen and nitrogen primarily. That's what you would have. And then you would have the metallic element of it from the anode itself, which would be
Nickel,
iron, nickel, and copper. And then again, because you have anode bias at the surface and the first most levels, okay, you would have oxide buildup on the surface of where the clay goes through, where the anode first starts going through the clay.
so would that be an iron?
Well, it would be iron, nickel,
Okay,
and chromium. Okay, oxides.
right.
And then you would have a diffuse state, a gradient in the material as it got more as the anode diffused out, right? And because you have hydrogen bias on the cathodic side, you would then go into a hydroxide bias at the cathode side, and there would just be a gradient between them. Now, where in the material that gradient is, I'm not saying it's dead in middle, right? It's probably north of the middle line toward the anode side, where it starts to become a hydroxide. Now, what's interesting is the chemistry element of it, right? Because now you have hydrolysis in play, which is a whole other story because you're dealing with water, moisture, and ionized hydrogen. Okay, the combinations that could be created of the metallic ions, okay, could become much more complicated. Because hydrolysis could break down that into lesser and greater forms of matter. And that's where it becomes fucking really interesting, because we would perceive that as possible transmutation, but realistically, all it is induced. It's induced hydrolysis, a chemical reaction at that point. So, it's pretty crazy. I don't know, but you could see your little bead at the bottom that we were saying, okay, black carbon, right? It's metallic, bro.
No, it's totally metallic. I was going to point that out. You could see kind of like a nickel in there or something like that, something that's shiny. We need to get it tested because it's looking an awful lot like we have signatures in there that other people have come up with as well. So it's something that definitely has to be tested.
This, by the way, also opens a whole entire material science end of things. That whether or not you're making RAV doesn't actually matter. Just the idea that you're able to use anode cathode to create controlled ionic deposition within the porosity of substrate means that you can dope a material in whatever fashion you'd like. You can basically print your doping material in like you would a 3D printer into already formed material. You can do all sorts of, like, the implications are friggin' radical. Okay.
Yeah. So this surface right here shows all the shiny stuff, Joe.
Yep, I see. And by the way, all my experiments have that too. When you start to get through the surface a little bit and it starts to, like, I don't want to say chew away, because at least in mine it didn't chew anything away. It was more just like a change. But you can actually see small metallic deposition, like little spots, little tiny spots.
It's interesting. We'd have to clear off each spot with a razor blade to see how much it digs in, if there's any material that's digging out of that area, or if they're popping out of the center of the RAV itself. You know what I mean? Which one is it in slow motion? What was going on?
Yeah, I don't know, man. Like, the way that it deposits, it's depositing in a supercharged material. Supercharged.
No, I get it, but it's flattering.
Welded, it's fused. Like, all these depositions are not built upon, they are fused to, right? And that's it.
But I understand that, but this isn't running the RAV all over the place. It's spitting out something. So what I'm wondering is if
what it's spitting out might, right? I mean, that might be relevant.
That's what I'm trying to say. Is
I haven't seen mine spit out anything. I'm sorry. That's why I didn't even realize, to be honest.
Yeah, no, and it could be from the part where it's burrowing down, where it just blasted it out and broke the rock or broke whatever it's doing there. It could very well be that. I just want to see if it what kind of material it is, and if it transformed from something. If there's anything in the clay or anything that would say that it's part of it or not part of it, or if it was something that picked up, you know what I mean, based on just the charged whatever, the ionizations, however you want to say it, the gases.
Right. I mean, it's like I said initially, which, like, I mean, it was my initial knee-jerk reaction to think this was, you have this charge exchange going on intramedia. You have a high iron content in the clay itself, or at least iron oxide, which, like, basically might as well just be iron, because you could, remove that oxide element of it through heat pretty quickly, right?
Mm-hmm.
So I was thinking that it was ionizing, and that it might still actually be doing that. Also ionizing the medium material as well, and then drawing that in through those ions, and that's probably happening also. This is just like a little sidebar element of it, but again, it's, the fact that it's happening is insane. The fact that it's observable is insane. The fact that in yours it burrowed all the way through and decided, you know what, we have excess, basically,
Yeah.
like, so push it out further. Like, I mean, that's insane. And you said that the texture of it when it came out was like it was spray deposited. You said it was loose, crumbly, you know.
It's a real crumbly. It felt like carbon. It like, how do I say this? In the way that uh like if you get something in your grill or something and it builds up as like a little
I
charcoal
know.
piece and then you smash it and it feels like a little dusty kind of thing.
It's like almost hollow. It's like, yeah,
Yeah. It's in
right.
a real
And
cavernous state.
well, doesn't that make sense? Because it's blasting ions through the material, but it's
Yeah.
solidifying in place as soon as it hits the water. And it's like it's not taking time to crystallize or set or anything. It has nothing to do that too. So it's just freezing in place, and then it's accumulating over time. So it's basically just made up of loose particles that aren't fused together because they came into contact with the water, and that's what you got. It's crazy to think. I mean, realistically, that's just probably a mass of accumulated ions. You know, I mean, not, and I say probably, but no, it's exactly what it is.
Well, that would also mean that gives it to a transmutative state when you have that. You know what I mean? There's a process which is going through to give you something that's transmutation, or it's giving you new material based on those things. So it'd be good to find that out.
So now, when it's an arcing, okay, so here's where the nuance comes in. Okay, when it's an arcing stage before the channel itself is formed, aka it's doing the deposition into the material. It's already picked the spot. It's doing it right.
Hmm.
Whatever spot forms is the one that it's going to go to. Now, it's not necessarily black at that point. You might not even see it on the surface. Like maybe if you turned it off before it formed, you'd see a little discoloration. Okay, it's not fully formed at that point, but it chooses that spot. That's the point it's going for, and then it
Hmm.
commits to it, right? Now, when the RAV forms, that's when the process accelerates as far as its formation. Now, in the pre-RAV state, all it's doing is what I said. All it's doing is what I said, right? Now, it will continue to only do what I said, okay? If if you turn it off and then you're like, okay, cool, right? And then you move on with life. Now, as long as you keep the water and cathode element to it, all right, that's the more hydrogen that comes in. Now, what the hydrogen is important in this case because as long as you have the hydrogen electron feed, okay, and you have the hydrogen coming up to the surface, you have all these valence electrons that are able to be stripped out, right? And they're feeding the anode, and then the anode is the one depositing all the stuff. So if you have an excess of free electrons and it's feeding the anode, and then it's getting caught up by what's coming out, well, then you have the very high potential for transmuted properties at that point because your valence electrons are just free and abundant, and anything that they're going to want to attach to, they're going to. So if you have ions traveling the other direction, well, those valence electrons will hitch the ride rather than feed the anode. So that's where your transmutive potential comes in, is once the RAV is formed and that hydrogen lead is left open. You do away with it, well then, at that point all you have is pretty much a one-way exchange. And that's why it works, by the way, like without the water and stuff in the cathode, because it has that negative charge bias. It's able to get enough electrons that are not necessarily like free electrons out of that potential that's already built, right? So it has that one-way draw, but it's actually not giving back to anything at that point. Like the anode is just like, okay, well, whatever, I'm just being fed. It's fine. And like that might kill the internal geometry of the RAV itself. And aside from killing the internal geometry, like you'd also deplete your well, although not in every state. Sometimes you could actually get a permanent cathode is my understanding of it. But whether it's permanent or, you know, like as a half-life, I mean, that we don't know yet. We really, I don't think any of us have let this experiment sit for so long that we know.
Yeah. I wanted to show this, Joe. I was showing it a minute ago. Sean said he polished his aluminum. So I see a ball on the top, just so we know. So it's not a hanging wire anymore. So it's not running around everywhere. And I can't see the bottom of it to tell you, but I could definitely see a ball down there.
It's a ball, and it has a transverse axis, and it disappeared. Then it did that.
Yeah, we
I mean,
got some high voltage going in there. That's for sure. Look at that.
I mean, by the way, the transverse axis is an interesting and expected phenomena. Like, you know, when you look at my 369 charts, you know, my alpha omega ankh, or as I like to put it, you know, alpha omega, you know, shiro,
Mm-hmm.
right? What that shows is exactly that you would get that middle vector like that beaming out. And that's actually an indication of self-grounding capability. So there's always the potential that if the thing were to know how to feed itself, it would.
So hold on. Would we call this a RAV now? Because you see the ball, it's in a different state. So what do we? I mean, he says calf, so I'm just trying to figure out.
I don't know.
What side do you fall on, Joe?
It's hard for me to explore without understanding the full setup, and also, you know, just like the whole, like everything. Like I would need to understand everything about it. It's stationary. I don't know that it's rotational. It appears that the arc that forms it is. But the nature and movement of the plasma in this particular circumstance does not appear to be rotational. Aside from that, you know, I think that I don't know. Like, again, I would need to analyze this and understand the setup, and I'd rather just not do it off the cuff without those details. So.
No, not a problem. I disagree with that, though. I do believe that plasma is rotational.
I mean, okay, well, now it kind of appears rotational now. Before it didn't.
Yeah, I don't think I would classify this as a RAV, but something more like ball lightning. We'll go with calf for now, but I think it's going to prove out to be something else.
I mean, at the end of the day, you've successfully, and I appreciate that you've successfully fixed the position and gotten rid of the instability.
You got rid of that little wire.
Right. Well, I mean, right. Well, what was fascinating about and entertaining about the other one was an instability.
Yeah, no, I get it. By the way, there's something for your camera effect, Joe. Right above it, you could see a sphere in a different color. Right where the thing's wiggling. Yeah, you could see that.
And it's fixed. It's fixed in place.
Yes, it is. So just something for you to look up later when you look at this video.
Yep. That might not be that particular thing because of where it was and the lack of camera motion at the time that it was there. No, it's still there.
Yeah, it's still there.
That might not be a lens effect. So that might be, like, you know, worth a conversation. It's still there, see? And it's relative to the sphere.
But you see the bottom looks flat now, and you see how the voltage builds out to it. Remember I was telling you high voltage just picks one spot and goes with it? So
I mean, just to be clear, so we have the anode and cathode at a 90 degree at a small distance, and then we have the camera angle at 45.
it looks like,
you know, slightly skewed. That's what we're dealing with, right? Okay.
Yeah.
I mean, okay. So, I mean, this particular RAB phenomena is very, very small. That's incredible that it's sustained.
Yeah.
Very, very small. Very cool. I mean, I call it RAB just because whatever, but I just saw another sphere come out and kind of come back in, you know.
No,
So
no, I mean,
it's,
look, it's all new, Joe. It's all new. So
listen, I need to explore this, and I hate to be ever the naysayer that shoots something down, right? But I mean, I don't. I'm failing to see the practical use.
well, I don't care what the practical use is.
Well, it looks great. Let's put it that way.
Well, you got to understand. I think this is more like
Oh, that was so rad. Whatever is just happening right there. I don't even know what just happened, but that was sick.
yeah. This is more like high voltage in the atmosphere building out a ball lightning. Okay, it's just that kind of effect.
Yeah, I don't disagree with that.
So it's not a RAV in the way that you think, and it's not for power generation or propulsion or anything else like that. It's proving out an anomaly that happens, you know what I mean, to our planet.
I don't disagree. And honestly, the stability of it is like
It's amazing.
literally amazing. There's no rhyme or reason. I know it's kind of fixed, but at the same time, there's no rhyme or reason why that would be as stable as it is. Like, look at how wild it is in its formation. I need to explore this myself.
Yeah, that's a lot of
On my
voltage,
on
by
my
the
own
way.
time. I saw it form right there. I mean, in real time. That's cool. Like, I need to break that down frame by frame to really get the gist. Obviously, anytime you remove air from the equation, it's just one less factor. But
Mm-hmm.
you know,
That's cool.
Sean,
All right.
I'm gonna be dissecting this. I will get back to you with my full analysis on this in due time. You know, it's makes for great TV, brother.
I think it's amazing, man. All right, guys. We're gonna get out of here for the day. We're gonna be in Discord for a little bit. So
Right
let
on.
me go ahead and
Drop the link. Listen, if you're not in Discord, get in Discord. Tell me I'm fucking retarded. Tell me I'm wrong. Argue with me. I'll sit there. So I'll say nothing sometimes. Like, do the goods, man. Get in there. It's Friday
yeah.
night. What else you got going on? You're already here.
Oh no. So later on today we're doing Mike show and he starts around 6 p.m. And that's on Faraday Research Channel. Give me just a second. Let me pull that up for you.
So you got 9 o'clock, got Mike, and then that's my time, Eastern time, for those in the majority of the population on the this side of the country. That's 9 o'clock. And then what time are you going on the other show?
Okay, so there's Mike's leak right there. Yeah, so what is it? An hour and a half will be on Mike's show with him, and then I'm gonna go on at 7:30 my time.
10:30 Eastern.
Yeah,
Yep.
to be on Traveling Fools channel, and it's more like a Art Bell type situation. The guy that announces it has a total radio voice that's completely awesome, by the way. And they're really down to earth people just like us, man. And they're into a lot of stuff that we're into. So, yeah, it's going to be some of a collaboration that'll go on from this a little further. So it's really cool.
Nice. And that's alive?
That's
Or is
going to be live. It's going
that's
to be
live?
streamed.
I love that. All right, awesome. I'll be there trolling your ass.
Yeah, it'll be streamed on my channel and theirs, just so you
Oh,
know.
very good.
And they'll be dropping the links for both in the chat as we do it. And we'll just go into everything. So it's going to be a fun night, man. It's going to be a long one for me, but it's going to be fun for everyone else.
And then don't miss the cast tomorrow where we are going to not botch that presentation somehow. Still going to have to figure out how the hell we're not going to botch that because we only know how to operate like this. But guess what? We're going to do it. We're going to. And it's going to great. It's going to be great.
Look, we almost had it ironed out the first time. Just a few nuanced things. I think we'll be just fine.
Yep. As soon as we set the ground rule of as soon as a picture goes up, if there's no narrative, we talk about it.
Yeah.
Okay. Then we're fine, because that was the only problem. Like, really. So
Yeah. So later on tonight, guys, at 7:30 my time, which is 4:30 now. So in about 3 hours, just tune back into my channel and I'll be streaming live. Okay. So you don't have to worry about it. Just look for my channel about then. So we're going into Discord right now. So probably in the next 15 minutes or so.
Let's go. 5 minutes, 10 in there.
So the link is in the chat here. So guys, I just want to say thank you to a couple people. Jiggle Jess, thank you very much, man, for the $2. Darren, thank you for the 5, brother. I gave out 5 Old Man Builds memberships, guys. I hope you guys all enjoy them. So we're doing awesome, brother. With that said, have a great night.
Peace, love, and fuck Marxism.
Always something.
The old man builds. The old man builds. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.